Today we will learn our final way to solve systems, which uses Cramer's rule. And here is our definition of Cramer's rule. It is just a method of solving systems using the determinant. So we're going to let A be the coefficient matrix of our linear system. If our determinant is not equal to 0, then our system has exactly one solution, and here's how we find it. So it's a little strange. First of all, notice that we're going to divide our solutions for our determinants for the x and y matrices by the determinant of A. And notice we have what our system equals, or would be our matrix B. When we find x, we're going to replace the x column with what the system equals, and when we find y, we'll replace the y column with what the system equals. Notice for x, we have coefficients a and c. Right, so when I find y, the x column remains the same. However, we change the y column to be what the system equaled. And our y coefficients are b and d. Let's try some. So notice our example says we're going to use Cramer's rule to solve the system. So the first thing we will do, is we will find the determinant of the coefficient matrix. And remember our coefficient matrix, we're thinking the 8, the 2 for column 1, the 5, and the negative 4 for column 2. Okay, so our determinant, 8 and 2 is our first column, 5, negative 4, the second column. Remember we start our diagonals from the top left. 8 times negative 4 minus 2 times 5, which would be negative 32 minus 10, or negative 42. That's the first step. Second step is to find x. And remember, to find x, I'm going to take my coefficient matrix, but I'm going to replace the x column with what the system equals. So my new first column is 2, negative 10. And the second column remains the coefficients for y. And we're going to divide by our answer from step 1. So we're going to divide by negative 42. And now we're going to find the determinant of the numerator and simplify. So we'll start at the top left with our diagonals. 2 times negative 4 minus negative 10 times 5 all over negative 42. And we clean it up. Negative 8 plus 50 all over negative 42, which ends up being 42 divided by negative 42, or negative 1. Now we're going to do a similar process and find y. Oh, I keep hitting the wrong tool. So to find y, this time I want to replace the y column with what the system equals. So the original x column, 8 and 2, will be first, and then for the y column we'll replace the 5 and negative 4 with the 2 and negative 10. And then we will divide with our determinant from step 1. And same process, we're going to find the determinant of the numerator. Diagonal start in the top left. So 8 times negative 10 minus 2 times 2 all over negative 42. Or negative 80 minus 4 divided by negative 42, negative 84 over negative 42, which is just 2. And then last but not least, we always write our solution as an ordered pair. X is negative 1, y is 2. And that's it. Cramer's rule. Take a minute or two and try this example you try. Okay, so hopefully you found the solution for the u-try to be x is negative 3, y is 7. Now we start talking about Cramer's rule with a 3x3 system. So it's not as quick, but it is the same idea for algorithms. So notice it's again a method for solving a system of equations using a determinant, and we're going to find the determinant of the coefficient matrix again, which would be you would have the x column, the y column, the z column, and then find the determinant using the diagonal method as discussed earlier. Now notice this time our system equals JKL, so when you find X, you replace the X column with what the system equals. To find Y, you replace the Y column with what the system equaled. And to find Z, you replace the Z column with what the system equaled. All other coefficients are the same as the original system. So we're going to practice using Cramer's rule to solve the system. And the first thing I would do again is to find the determinant of the coefficient matrix. Okay, so we know our X column 1, 1, 2, Y column is 2, 4, 3, and the Z column is -1, -2, and 1. And remember, to find the determinant of a 3 by 3 matrix, you have to copy the first two columns. And then we do our diagonal starting from top left. So we know we will have a 4, because 1 times 4 times 1 is 4. Move to the right. So 2 times -2 times 2 is -8. And -1, 1, 3 product is -3. Remember, you will subtract the diagonals going from bottom left to top right. So 2 times 4 times -1 is -8. 3 times -2 times 1 is -6, and 1 times 1 times 2 is 2. And then we simplify, we clean it up. This ends up being -7 minus -12, or this is just 5. Okay, so that's the first step. Now, next step, to find what X equals, we're going to replace the X column with what the system equals, so that column becomes -4, -6, and 3. And we will keep the coefficients for Y and Z. So the Y column 2, 4, 3, Z column -1, -2, and 1. And just like we did before, we're going to copy our first two columns so we can do diagonal method. Oh, I also forgot to tell you, remember to divide by your answer from step 1 to find X. Remember, we always start our diagonals from the top left, so -4 times 4 times 1 is -16. 2 times -2 times 3 is -12. -1 times -6 times 3 is +18. And we will subtract the diagonals going from the bottom left to the top right. So 3 times 4 times -1 is -12. 3 times -2 times -4 is +24. 1 times -6 times 2 is -12. And again, this is all divided by our coefficient determinant 5. Okay, so all you have left to do is to clean it up. -28 plus 18 is -10. Plus 0 over 5, this would be -2. Now we're going to find Y. So Y equals, notice this time we'll replace the Y column. The Y column with what the system equals. So the Y column becomes the -4, the -6, and the 3. The X and Z columns remain the same as the original coefficients, and we'll divide by our answer from step 1. So just like we did before, we're going to copy the first two columns so we can use our diagonal method. Diagonals always start from the top left. -6. -4 times -2 is 8 times 2 is 16. -1 times 1 times 3 is -3. And we will subtract the diagonals from bottom left to top right. So 2 times -6 times -1 is +12. 3 times -2, -6 times 1. 1 times 1 times -4 is -4, and this is all divided by 5. To clean it up, notice we'll have 7 minus 2 over 5, which gives us 1. And then last but not least, we're going to find Z. Okay, so that's our next step. So z is going to equal, we'll keep our coefficients of x, 1, 1, 2, our coefficients of y, 2, 4, 3. This time, our coefficients of z become what the system equals, -4, -6, and 3. And then remember, we'll divide by our answer from step 1, the determinant 5. So we're going to recopy our first two columns so we can find the determinant. And remember, our diagonals start in the top left. So 1 times 4 times 3 is 12. 2 times -6 times 2 is -24. -4 times 1 times 3 is -12. And we'll subtract the diagonals going from bottom left to top right. -32. 3 times -6 times 1 is -18. 3 times 1 times 2 is 6. And this is all divided by our determinant from step 1, 5. So when we clean this guy up, notice we'll have -24 minus -44. Nope, I have a mistake somewhere. Oh, it's double negative. Let's see, so what is that? 20 over 5 or 4. And then remember to write your solution as an ordered triple. So x is -2, y is 1, and z is 4. And that is Cramer's rule of a 3 by 3. Please take a few minutes to try this final example you tried. Okay, so hopefully with this example you found the determinant of the coefficient matrix to be 58, x to be 2, y to be -3, and z to be 4. And make sure to write that solution as an ordered triple. We made it through Unit 3, hooray!